If you have data that's organized into a linear list that is also in sorted order, then there are some shortcuts you can take when you're conducting a search. If the data isn't sorted, then your approach is going to have to be probably sequential, where you start with the first thing in the list and then you just examine the items one by one until you get to the end. But if you can order the list, then you can use a technique called binary search. So in this example, I want to show you just diagrammatically here how you can conduct a binary search. In this example, let's look at a sequence of words. So we have bake, call, jail, look, moon, all the way up to zoom over here. So we have 10 words in a list, and they are in alphabetic order. Up above, I've listed a index. So if we were to store these 10 words into an array of strings, then the index of the first one would be 0. The index of the last one is going to be 10. So I guess we have a total of 11 words here. This is how you can search through this for a particular word. So let's suppose we want to look for the word star. Well, how do we go about doing that? One way that we can do that is as follows. So let's look at this example. We'll do a pass 1. What we'd like to do is we would like to take the word that we're looking for, and we'd like to determine, is it in the upper half of the list or is it in the lower half of the list? So if it's in the upper half of the list, as in this example, then we can eliminate all of the words in the lower half. So we can cut our search space in half by doing that. We can eliminate half of the words immediately. So that's the approach here. So here is what we need to do. Let's use 3 variables. One is first, one is last, and one is middle. And we are going to set those to indices. So first, to begin with, is going to be at index number 0. And the last is going to be at index number 10 over here, as you can see in red. We want to use those to calculate the middle index. So it's a simple calculation. Okay, middle is just the first plus the last divided by 2, which in this case is 10 divided by 2, which is 5. So that means the index of the middle word is here at index number 5. So we take the word that's at that index and we compare it to the word we're looking for. So is pass equal to star? Okay, in the middle we have pass. We're looking for the word star. So we're asking this question. We're writing an if statement. And is pass equal to star? Well, no, it isn't. So we need to keep going. Then we want to know, is star greater than the word in the middle, which is pass? And yes, it is. So knowing that, then we can eliminate all those words to the left, the lower part of that list. We can reset our index first to middle plus 1 in order to do that. So that means then that first is 0 to begin with, middle was 5, so when we set it to middle plus 1, first now becomes 6. So now we have first over here, and we've eliminated all the words that you see in yellow. So now we're going to be looking at the upper part of the list, which is just those 5 words. All right, so now we have reset first. First is equal to 6. So that's the index of the first word in this upper half. We didn't reset 10. 10's still at the end. But now we compute the middle again. So this time we have first plus last. So we have 6 is first, 10 is last. So that's 16 divided by 2. And that gives us another middle index, which is 8. So now the middle of this reduced list is tall. Then we ask the same questions again. Is the word tall equal to the word star? We're trying to find star. No, it's not, so we need to keep going. So then we test. Is star greater than tall? Well, in this case, no, it isn't. Okay, star is less than tall. So the result of this test is false. That means we can eliminate the words that are greater than the word at the middle index, tall. Since star is less than tall, we don't have to look at the words over here. So we're going to reset last this time. Okay, so last is going to be set to middle minus 1. So middle is 8, so we end up setting last to 7. So now, last is set to 7. We can eliminate the words to the right of that middle index. So those 3 words, tall, wind, and zoom, they're gone. So that means now we're down to just 2 words, and we've eliminated half the words again. So the first time we eliminate half, the second time we eliminate a half of the remaining words, and then we just keep going. So now we're down to just 2 words. We have roll and we have star, but we go through the same steps again. Okay, first is 6, middle is 7, last is 7, so we calculate middle. So this time 6 plus 7 is 13, and when we do integer divide, we get 6. So we are going to have middle as 6. We'll compare the word at the middle, which is roll, and is it equal to star? Not yet, so we need to keep going. We haven't reached the end just yet. So then we do the test. Is the word we're looking for greater than the roll at the greater than the word at the index roll? And it's true this time. All right, so in that case, since the index of star, the word star is greater than roll, then we want to move our first index over to middle plus 1, following the same set of steps. So by doing that, then first is set to 7, last is set to 7, and of course when we do the calculation for middle, then the middle index is set to 7. So then we're done, because index 7 contains the word star. So we test to see if the word that we're looking for is at the middle, which is 7, and this time it is. So we're done. So that's how the binary search works. We just keep reducing our search space by 1/2 every pass through our loop until we finally find the word. Now, it's possible that the word is not in the list, or if you're doing numbers, the number is not in the list. And it's easy to detect that condition, because if the first index ever exceeds the last index, then that means the word's not in the list. So the binary search then is a pretty neat way to quickly search through an ordered list. Now, let's go look at some C++ code to implement it. For this example, I'm going to use the word scramble problem that we did in an earlier video. So in that case, we used the dictionary of 4-letter words, and we entered a scramble. Then we used the dictionary to determine if we could pick out any words from the scramble that matched words in the 4-letter word dictionary. So I'm going to modify that program a little bit. In that example that I was talking about, we did what we call a sequential search. We started with the first word in the dictionary, and then we went to the second one by one, all the way through until we either found the word or we reached the end of the dictionary. If we can read all of those words into an array, then they are already in an sorted order, ascending in alphabetical order, then we can employ the binary search to solve the problem, and then we can shorten how many tests we have to make, how many comparisons we have to make with words in the dictionary to the test word that we have. So we have the same stuff to begin with as before. We have to open up the dictionary. We have this string for scramble. We have word and test word. What I've added here is this. I want to make an array of strings, and I'm calling it words, and there are 4,030 words in the dictionary, so that's how big I'm going to make this array. Now, we just looked at the binary search, and you saw that there were some variables there that we used. So I'm going to use those here as well. So we have first, and that's set to 0. Last, the beginning value for last is the last index, so that would be 4029. Middle, I'm just declaring it, setting it to 0. And K, I'm going to just use that as an index when I'm reading in the words, and that's set to 0. We open up the dictionary in the usual way, but this time I want to load all of the words into the array. Right? So we need to add some code here. We want to load the dictionary into the array, and I'll use the same loop here as I used in a previous example. So I'll paste that in here. And it's just a while loop. Okay, while the dictionary is not at the end of the file, then we'll use our file pointer and we'll input the words directly into the array called words, and we'll increment our index k as we do so. So that will load up the array with the 4-letter words from the dictionary. All right, now we need to enter our scramble the same way we did before. So we'll prompt ourselves or a user to type in a word scramble in lowercase letters, and we'll use cn to read that in. Then we will start out with going through this scramble, picking out 4 characters at a time, just as we did before. So as long as the position is less than the scramble length minus 4, okay, remember doing the 4-letter words, we don't need to look at the last 3 positions because those don't make a 4-letter word. Then we still have that same while loop established here. We will get a substring from that scramble using the substring method, and we move the position along, position 1, 0, 1, 2, 3, 4, all the way up until we get to the end. Now, once we have our test word, then we want to compare it to the words in the dictionary to see if it's an actual word or not. Okay, so the test word, it's just going to be 4 letters out of the scramble. So sometimes it'll be a word, most of the time it probably will not. Depends on how many 4-letter words we put in the scramble. So instead of the code that we used last time, where we have to go through the dictionary 1 word at a time, we're going to use the binary search in here in order to look for whether or not this test word exists. All right, so let's get the code for the binary search and let's drop it in here. All right, so let's paste in our binary search. So I'm putting the whole thing in here, but we just went over an example, so the code is going to reflect that example. All right, so we have the test word, and we have the words that are in the array, the words array right there. All right, so here is our loop. While first is less than last, now remember, to begin with, first is 0, last is 4029, the complete list of words. We calculate the middle, so we get the index for the middle word. Then we test it. Is the word in the middle the test word we're looking for? If it is, then we found it, and we'll print out word, test word found in the scramble, and then we're done. We'll break out of this loop, and we're finished. We found the word we're looking for. If it is not, then we do the other tests. Is the word in the middle greater than the test word? Okay, so if the test word was like a bird and the word in the middle is lake, then lake is greater than bird, so we want to reset last. Okay, so that would mean that our word is in the lower part of the complete list of words. So we're going to move last down to middle minus 1. So we're throwing away the upper half of the dictionary of words, so that's about 2,000 words. Okay, well, if that's not the case, we'll test the other one. If the word in the middle is less than the test word, okay, so that means that the test word is going to be in the upper half. So if that's the case, then we're going to move first up to middle plus 1. And in that case, we're going to be throwing away the other half of the dictionary. So in one case, we will reset last, and in the other case, we'll reset first. Now, the final part of that is if we don't find the string at all. So if we get a string that is not a word, then we will have gone through these if statements, and then we will not have found the word, in other words. So we've searched all the way through, we didn't find it, so first now has become greater than last. The index crosses over, and when that happens, that means that the word's not in the list. So if first is greater than last, then we'll print out the string. Whatever it is not a word, and that's the end of the binary search. Okay, so this is the C++ implementation of that diagram that I just showed in the first part of the video. Well then, this goes through and it takes care of one of our substrings from the scramble. Once we're finished with one, we want to go back and get the next string, the next substring. So position has to be updated, and we need to reset the indices so we can search again for the second substring. We have to increment position. We need to reset first back to the beginning and reset last to the end. And in doing so, then, we are preparing to search for the next substring that we pull from the scramble. Now, let's compile the program and run it. Now let's look at the output. So the dictionary file opened. That's good. Now it wants us to enter our word scramble in lowercase letters. So I'm going to use the same one I did in the previous video. So we'll put that in, and now our program will try to locate words that are in that scramble. Okay, so AXBI, that's not a word, AXBI. The next four characters, XBR, that's not one. But then we find bird. Okay, so bird's found in the scramble. So sure enough, there it is. Then we move along one character at a time. So that for those four are not. And then we move along and we find date. Okay, so date is found in the scramble. Then there are several substrings here that we get that are not words. And then we finally get to lake. And then lake is found in the scramble, and that's the last one. So this works just fine. And the real advantage here is that you can test all 4,030 words with about 10 or so tests maximum. And if you're doing it word by word, it's possible that you might have to test every single word, all 4,030 of them, in the case where you don't have a word. And in the case of the binary search, the maximum number of tests will be far, far less than that. So the advantage of the binary search is that it's a very efficient search mechanism, but it has to work on an ordered list. The numbers have to be in ascending or descending order if it's a set of numbers, and if you have words like we do here, then they have to be in alphabetical order. So there's a good example then of the binary search. One other thing that would be nice here is that little algorithm, that little while loop there. You can probably understand that that might be a really useful thing to have in the future. So we might want to make that into a function instead of just putting the code directly into the main program here. Now, I'm not going to make that function at this point, but in a future video, we're going to use a binary search function. Okay, I think you've had enough for this video, so we'll stop here.